All extrema, or minimum and maximum points, happen at critical points, a point where the derivative equals 0 or is undefined. Because no matter how the extremum looks like, the tangent line at that point is always either flat, the derivative equals 0, or is non-existent, meaning the derivative is undefined. Okay, so if we found a critical point, how do we know if it's a minimum, maximum, or if it's none at all? Candidate points are all the possible locations where there is an extremum, or a minimum or maximum point. This includes all critical points, and if you're looking at an interval, it also includes the endpoints, since they may also be a minimum or maximum. To find out for sure whether a candidate point is an extremum, we use the candidates test. Now, before we dive into the candidates test, check this out. All maximum points follow a specific pattern. Before we reach the maximum point, the function is always increasing, so the derivative is positive. And then we hit the maximum point, meaning the derivative is 0 or undefined, and then after the maximum point, the function decreases, so the derivative is negative. Whenever the derivative goes from positive to 0 to negative, the critical point is a maximum point. For minimum points, just flip this around. Before the minimum point, the derivative is negative, as the function is decreasing. Then, we hit our minimum, where the derivative is 0. And then, after that, the function increases, so the derivative is positive. Thus, whenever the derivative goes from negative to 0 to positive, the critical point is a minimum. So, whenever a function goes positive derivative, critical point, negative derivative, the critical point is a maximum, and whenever a function goes negative derivative, critical point, positive derivative, that means the critical point is a minimum. Awesome. Now that we know how derivatives relate to extrema, back to the candidates test. In the candidates test, we find all the candidate points. Remember, those are critical points and endpoints that might be minimum or maximum points. Once we have all our candidate points, the place to look is the intervals divided by those points. For any of these intervals, the derivative will consistently be positive or consistently be negative, because whenever the derivative changes signs, we will encounter a critical point, and all the critical points are candidate points. From these intervals, we can then find out if a candidate point is a maximum, minimum, or in some cases, if it's neither. Now, this is best explained in an example. Can we find if there are any maximum or minimum points on this function? The first step to do in this is to find all the candidate points. Since we're dealing with the function as a whole, not an interval, we're only concerned about critical points, and that requires the derivative. So what's the derivative of f of x? Well, using the power rule, we know the derivative of negative x cubed is negative 3x squared. The derivative of 6x squared is 12x, and the derivative of negative 9x is just negative 9. And we also know the derivative of 4, a constant, is 0. So when does the derivative equal 0? Well, let's factor this out. First, let's factor out the negative 3, and then we can factor the polynomial, which we know is x minus 3 times x minus 1. So when does this equal 0? When x equals 3, or when x equals 1. Great. These are our critical points. Now, are either of these maximum or minimum points? Let's check the derivatives in the intervals. First, let's find out what's happening with values less than 1. We can pick any value less than 1 to test. 0, negative 4, negative 10. No matter which value we choose, we see that the derivative is always negative. So the function is decreasing before 1. What about between 1 and 3? To test, we can use any number between 1 and 3, and the derivative at each of these values is positive. Thus, we know the function is increasing between 1 and 3. And our final interval is any value greater than 3. Again, we can pick any number in the interval, and we see that the derivative is negative. The function is decreasing. So, are there any maximum points? Well, yes. Before 3, the function is increasing. The derivative is positive. And after 3, the function is decreasing because the derivative is negative. So that means 3 is a maximum point. Is there a minimum point? Well, before 1, the function is decreasing, and after 1, the function is increasing. Thus, we know 1 is a minimum point. And checking out the graph of our function, we can give ourselves a nice pat on the back. Okay, now, just as a terminology note, we call these loco extremum. 1 is a loco minimum, and 3 is a loco maximum. Because, yes, they are the lowest and highest point with respect to what's around them, but as you may notice, this function has values that are more extreme than the ones we found. So how do you know if a point is an absolute extremum, or if it's the largest value or the smallest value in the entire function? It's easy. We'll dive into that in the next video. If you like this type of content, keep this channel going by liking this video, subscribing to the channel, and sharing it with friends. Now, keep working hard and keep learning. Thank you for watching.